Hello everybody. This will be part of a series of videos about T-Trak Z. We're covering topics like example layout types, wiring topics, different types of specialty modules. I wanted to go over how to connect your modules via a bus and feeders. So I do have another video that talks about constructing these, what you need to make them, what it would look like. So I'm not really going to go into construction too much. And the standard calls out how to do the inside the module wiring well. So there's red, black, yellow, I believe are the colors, and they come out on the outlet in a prescribed way. So this video is about how you connect those up. There have been some questions about, okay, so the module is wired a certain way, but how do I connect them all together? How do I get it back to a power pack or a DCC control system? So I wanted to physically show what some of this bus would look like. Again, not really going to go into construction details too much. I have a video on how to construct this stuff, the materials you need. But the bus I use and I like. So let me back up. Everything outside the back of the module is up to the individual that provides the power and bus cables. So in T-Trak Z, it's a group effort. So you'll have somebody show up that may design the layout, may be the ramrod for the show. You may have the same person or a different individual that is providing electrical and power expertise. The person that is providing the expertise, sometimes it's even a group if it's a large enough layout. That person or group that provides the power expertise usually provides power and the cabling. So I'm going to show you how I do the cabling, and just to give you kind of a sample, kind of an idea about maybe how you could go, or maybe some of the other options you could do. But it's really up to you as the power provider to build a bus the way you want. I'm just going to show you the way that I like doing it. So we'll start with the standard interface at the module. So this module has red and yellow track, the front and back track feeders. So this is a module that has feeders. Not all modules need to have feeders. Some modules don't. This module will always be neighboring the one on the right. So I don't really need to feed every module. But the modules that do have feeders have a standard quad outlet. And what you need as provider of power and bus is you need to provide the mating connector. So this is what the mating connector looks like. It's two track circuits. And then this travels to your bus cable and travels to your power. Again, I'm going to show you how I do it. So I do, since it's two circuits, this is for, we're going to talk about a back-to-back layout. So this is a layout where I'm only showing you half of the modules, and where my hand is and where the wiring is, there's another line of modules with a small space in the middle for the wiring. So I run the two circuits, yellow and red, and in the middle, so I like to run 5-foot bus sections. I find that works pretty well in Z, and I've actually been pushing for that in all scales. A 5-foot piece of cable is a manageable piece of cable. It's easy to cable manage. It's easy to roll up into a bundle or put into a small roll of some kind. I use Christmas tree light rolls to roll these up into. But I find 5 foot is a manageable length. There are some clubs out there that like a 10-foot length. That's totally okay as well. Might be a little long of a run for Z scale though. So I'm not sure that it's a good universal size. So this is the bus, and again, I have another video on the type of cable and the construction, so I'm not going to get into that here, but I have a red and a yellow circuit, so two circuits for a back-to-back layout where you have two full loops of track. And what I do is I have the long bus sections that come to a feeder area and then continue on. I don't have the cables on this side, but the cables continue onwards. And I'll have a small bus section that's in the middle, and this is a inline section of feeders. What I do is I do inline, capturing the yellow and the red and its ground, and bring those out in cables. And then I supply that to a connector for the module. Now, the feeders that I build have two connectors. for the exact reason of having back-to-back modules. You can feed both sides of the layout at one time with this feeder. So this is how I like to build them. Let's see, I haven't really talked about Accessory, but Accessory, again, this is delineated in standards how exactly to do the connectors, the colors, everything. I have a video on how to construct. But the Accessory is white is positive, black is negative, 12 volt DC. So if you want to do lighting, turnout control, I actually have a module that has a small DC power pack. You can power small DC power packs with this type of accessory. But this is the same exact type of connector and cable. These are keyed differently, so you can't plug track power into them. They're mated differently, so I couldn't just grab the red or the yellow and plug this in. They're oriented differently for safety. Same idea, so I have two accessory connectors. So overall, when I take a layout to a show, I have a number of these feeders. Now maybe this is a busy area of the layout where I'm putting this feeder. Maybe I need a second feeder piece. I can put a second feeder piece in. Now I have 4 connectors instead of 2. Same thing for the accessory. There's only 2 accessory plugs here. Maybe there's a lot of lighting in the area where this bus is running through. Maybe I need to put 2 of those in. So that's the general concept. One end of the bus connects to a power source. It would be a pigtail that would run to your power source. I actually run a integrated power module. Let me flip around here. Sorry for the mess. I actually run an integrated power module. It has track and everything on it. It has all the power. There's power supplies underneath for the raw power. And there are connectors on the back. So this is part of the layout. I actually run track across it and run trains across it. And it has all my control. If you are doing a inner loop area, let me scroll back around. Sorry, excuse my panning. If you're doing a inside loop area where maybe you have a little small separate loop, as you see there, maybe you need a DC power pack on a short pigtail. And you can power that loop locally. And maybe you could run it off of the accessory bus. Rokuhan Power DC Power Pack runs really well off of a 12 volt accessory bus. The other topic I want to cover in this video, apologize it's running a little bit long, but I want to cover a dog bone type of layout. So a dog bone type of layout would be exactly what's shown here. And imagine that I'm backed up to a wall. So this is the area behind where people will see. But in a dog bone layout, the 2 tracks are really one track, right? So you need to only run one circuit for a dog bone area. You only need to connect one circuit. So if I was to run this layout as a dog bone, I knew it was all a dog bone layout, then what I would do is I would get rid of this yellow circuit. This would be the second circuit. And I would pull this yellow circuit off of the layout. Wouldn't have it there. Because a dog bone layout is only one circuit. So I like to depict electrically what's happening in the layout. So if I was to do a layout like this, I would just run the red cable. So if you just run a red cable, then how the heck do you power the modules, right? Because you've got yellow and red on the modules. So with this type of module feeder, I'm going to set you down for just a second. Hopefully I can do that. I'm sorry. This gimbal's a little challenging. Hold on. Okay. So if I was to do that, have the red cable running in here, right? So what I would do is connect. So this is powering the red circuit on the feeders, on these feeders here. It's powering the red circuit already. It's connected to the bus. What I would actually do is I would plug in the yellow section here with that same bus cable. Now, visually it doesn't look right? But it's, you know, a sacrifice you make, right? So yellow into red. And then this would continue on with the red cable, or whatever color you want. But I would plug in a red cable here. Since it's one circuit, I try to keep the color consistent. Usually try to carry enough cable to make it happen. So this is red, and this is yellow. So this would support a dog bone setup, as is. Now, there is also a way on this feeder cable to flip these around, flip these backwards. And these will plug in a reverse fashion. So if you wanted to flip the polarity on one of your lines, at a show last minute, you just had to flip the polarity on one of the lines for some reason. You really shouldn't need to do this, but if you did, maybe someone's module is not wired correctly, then you can actually flip this section end to end and reverse polarity of one of the sections. So I'm going to put this back to the correct polarity. But that's it. So this is how I do the feeders. This is how I do the bus. It's up to the individual modules, modeler. It's up to whoever's providing the power for the layout. That's who it's for. You can run matching polarity DCC. You can run opposing polarities. You can run 2 circuits DC. You could come to a show with 4 or 5 DC controllers and string circuits to each one of the loops separately. So it is up to you. But this is how I run my buses. I use the same connectors that you would use for the modules. And check my other video from construction methods and wiring sizes and recommendations. So this video has run a lot longer than I would like it to be. It's 11 minutes, so I'm going to cut it short here. Hope you find this entertaining. Please comment if you'd like to see more topics covered. I also participate in Facebook on the T-Trak Z group. I also participate in the main Z-Scale Facebook group and also on Trainboard. So please send in your comments. I want to make people knowledgeable about what they're maybe getting into or are interested in. So please help me help you. All right. Thanks, guys.